everybody. Is this thing on? I'm always nervous. It's like I'm just talking to myself. So yeah, I'm Cory. I'm the CEO and co-founder of MassDriver. We're a visual development platform for managing infrastructure with IAC, policies, and all of your security and compliance in place. I'm also the maintainer of Bonnie, which is an Elixir framework for extending Kubernetes, and the Kubernetes Elixir client. Been in the IAC space for like 15 years. I've written and deployed hundreds of Terraform modules, including 5,000 node Kubernetes clusters, which used to break GKE. I found that out the hard way. I've seen way too much Terraform, and I've got myself a concern. So what we're going to talk about today, we're not going to do a whole bunch of syntax stuff. There's plenty of tools out there to help you lint and make your code look better. We're going to talk about a couple of principles that I've seen people kind of stumble over. And the maintenance isn't just about the code. The maintenance is the actual cloud resources behind the scene. Like when you're doing code with IAC, it's so much different than what we're doing when we're writing applications. So we'll talk about some of the organizational impacts of infrastructure, codifying conventions, and trying to lower the cognitive load, which I think is one of the most important things I can do as an operator and a DevOps engineer to make it easier for my developers to self-serve and manage their infrastructure. At the end, I'm also going to demo something that is extremely raw. We're pulling out like the heart of MassDriver. We're kind of going backwards. We're open sourcing the core of our product over the next couple of months. And so I'm gonna demo that today, and it might freaking explode. So I don't know if you know this, but ops people's lives are very hard. All of our stuff's always breaking. We're always up at 2 a.m. So if this does implode, this is what I need you to do. Just clap anyway, and then pat me on the back and say, good job, on my way out the door while I'm crying. So who runs on the cloud today? Okay, who uses Terraform or some other IAC tool today? Who writes their own Terraform? Hey, good on y'all. Okay, so first, for people that aren't familiar, we'll just do a simple definition. It's managing and provisioning infrastructure through a declarative manner. You're focusing on the what you want, not the how to get it. IAC is integral in modern cloud ecosystem. It lets you get fast, consistent, scalable infrastructure. But at the end of the day, it's fancy JSON with some programming logic. Like really, you're just hitting APIs and pushing JSON up to, create a REST, hitting a REST resource and creating a Kubernetes cluster or database or whatnot. And I want to come back to this. Like it's really it's kind of a preprocessor more than a language or code. But that's just my opinion. And there are a dime a dozen. There's OpenTofu. Did you guys hear about that one? So we're one of the companies behind the push for OpenTofu, but of course there's Pulumi, there's Terraform, and there's CloudFormation, there's Crossplane, there's Puppet, there's Chef, there's Wingling, there's like Nitric, like they just keep showing up. And it's really funny because there's this age-old problem. People are like, Terraform's hard. And Terraform's not hard, it's a super simple language. Knowing the cloud services on the other side of the Terraform is the hard part. And I think people misunderstand that. Like, this thing is really, really hard. It's a pretty primitive language. This talk's going to center around Terraform and OpenTofu, but the concepts kind of apply to all declarative IAC tools. And, salt stack. Everybody forgot about that one. And this is what some regular Terraform looks like. It's just a pretty basic language. It's the only language that has like less if statements in your code base than like Elixir. And I also wrote one 15 years ago. You can go find this if you want. It's written in Ruby. It is a pile of trash. I would not suggest using it. I also haven't updated it. It existed before Markdown was supported on GitHub. That was a long time ago. So the benefits of IAC, consistency and automation are probably the most cited benefits. Minimizes manual errors by automating the provisioning process, leads to more reliable, predictable infrastructure. You get consistency across environments. Parity, we like parity, right? It also helps you scale systems faster with changing demands, right? So making it very easy to add additional compute, clone things. Maybe you need to bring up an additional Elasticsearch instance or Postgres replica the day before Black Friday, shut it down. I can literally just increment the number, that's great. Decrement the number Saturday morning. I think the most important things, though, are collaboration and version control. It's very hard to collaborate when people are just clicking around making resources in AWS, right? It allows teams to track changes in Git, roll back, understand the history of their infrastructure. And so that's, I think, probably the most important benefit to it. And there's actually something very scary here. I'm impressed that so many people in this room, I was actually thinking that this would be just because of the nature of these languages, we'd see more people in data centers and not using this. But if you look at the state of CD report, Can anybody guess, a wild guess at what number of companies are doing infrastructure as code today using any of those tools that we just mentioned? Think it's above 50%? No. You think it's above 30%? No, it's 27%, which is funny because everybody's doing DevOps and everybody's automating. And then you look at the state of CD report and you're like, how are you automating that? You're using like a click tracker in like Chrome? Like, what are you doing? And when you look at the DORA report, it's even scarier. Like the DORA report, everybody's like, hey, page 3, everything's great. You get to page 37, it's like 50% of us have 3-day outages. And it's like, this is scary, y'all. We're all moving to the cloud and yeeks. So the alternatives are ClickOps and scripting. ClickOps, manual process, prone to error, scripting, limited in scope. And with all things, there are 2 hard things in infrastructure as code. One is understanding the underlying service. It's not the IAC. Like, that's the real challenging part. And when I'm making modules in Terraform or whatever, I will go and literally read the entire docs on how AWS recommends to do monitoring, how it recommends to do alerting, how it recommends to do this or that. And they're like 60, 70 pages of just like learning a service. And then I'll go right to Terraform. The other hard things, anybody know what it is? It's freaking naming. And this is like the hardest one. It's naming, but it's actually grasping the use case of what you're trying to encode, right? And that's really key, and that's something where I'm gonna harp on this one a lot. So when you think about designing Terraform modules, I think one of the most important things is to focus on designing for a use case. You're creating specific solutions, not generalized ones, right? You're thinking of, do I need Aurora, the AWS service Aurora, or do I want Postgres? I probably want Postgres, right? And if I make a module that supports Aurora, what happens if I set some of those bin log options on a Postgres instance? It doesn't do anything, but the fields are there. I can still set it, right? What happens if I want to set some stuff for the wall on MySQL? The fields are still there. It doesn't do anything. I have overhead and stuff that I have to think about that doesn't matter. And if I kind of scope that down to what I'm trying to deliver, and we'll get into a couple of examples here in a second, it makes it much easier to maintain. You have a smaller interface to your modules, less overhead for the person who's looking at it and trying to execute it to think about. So let's look at this first one. Who's been to the Terraform registry before? Yeah, okay. Let's say you want to make an S3 bucket. This is the most complicated resource in all of AWS. Do you know how many, I got to double check real quick. Do you know how many attributes an S3 bucket has actually in AWS, not in Terraform? Like if you go to AWS and you hit the API, how many fields are on a bucket that you can set? It's a bucket. They name it, huh? Yeah, it's right around 98, last I checked. So they name it a bucket. Like, it's supposed to be simple. It's like I'm going to Home Depot and get one of those orange things, but it's like the most complicated resource, right? And so designing a bucket and saying, hey, you know, dev team, we've designed a really great bucket module. Here you go, 98 fields, figure out how to make a logging bucket. That sucks. But if I make a module and it's called our S3 logging bucket, and maybe I'll have another one for, I don't know, user assets like CSV files or images they're uploading, these things are going to have very different life cycles on how you do your rotation out to different storage levels in S3, right? And so logging, I might want to automate that entire process. Maybe for assets, people's images or static websites, I never want to move things off to cold storage. I can start as an operator to encode my expertise into this module. My developers don't have to think through all of these variables and try to figure out like how to configure this thing. They can just say, oh, I need the logging bucket. Here it is. Here's a name. And Cory took care of all my lifecycle policies to lifecycle off my logs. A really great one is getting really, really specific, right? S3 ETL raw stage bucket. This will maybe set up my FTP server to allow people to let FTP files into the beginning of a stage of an ETL pipeline. So I like to kind of think about these more in these use cases. And going back to the RDS one, there's RDS. It's a bear. It is a bear. Go look at the Terraform module. It is intense. Like the official, like canonical AWS RDS module is nuts. AWS Aurora is a subset of that. And then a subset of that could be AWS Aurora Postgres. And now you get to focus on like how do I make a really good Postgres module, not how do I make a capable RDS module, because you can't. You cannot make a capable Terraform module around an entire cloud service. And this is one of the things that absolutely drives me batty when I look at things in the Terraform registry. Your module should have a single name field. If you look at the VPC, like the official canonical AWS VPC module for Terraform, how many name fields do you think it has? It has 8. I want to make a network. I got some subnets. I have to think of 8 different names to even start using the thing, right? Like, let's make these a bit easier. Let's think about, like, what is the name of the use case that I'm going to be using this for? Is it my internal VPC? Is it an external VPC? And when you think about the naming convention, you can do this where you can just say, you know what, I'm just going to give you one name. I want you, developer, to give me the name of this Redis instance. You're going to use it for pagecast, or you're going to use another one for sessions. As the operator, I can do things like, A, define a naming convention and not make my developers worry about it. I can encode that into the module. You say, I want page cache, and out comes a really great name, the project that it's in, the environment that it's in, your use case right here, some random identifier you never have to worry about, and that's the name of my cluster. Give my key for encrypting the data, the exact same name, and I'm able to go ahead and kind of create all the replicas for them. I don't have to say, hey, what do you want to call replica 2? That sucks. You know what I want to call replica 2. I don't care. I'm doing cattle, not pets here, right? And so getting modules to have one name focusing around the use case and let your developers essentially invoke the use case that they want, pass in a name, and then take away a lot of that complexity for them and start to encode like your expertise into the modules. And so, oops, I had one more. I don't know what's going on. Clickety click. A bunch of animations that we didn't see apparently. So kind of going back to the registry modules, I purposely try to avoid using these whatsoever. I don't think they add a lot of value. They're too generalized. Looking back at, this is a hot take, some people love using those registry modules, but I'm gonna argue they have absolutely zero value. I know they've got millions of installs, but why? Well, people think that they add value. They go grab it, they go, oh shit, 1 million people have installed it. There must be something great in there. I don't know, this is the VPC one. It looks like they're just passing through all the variables that I pass in to the resource. Why wouldn't I just do that myself? Like it's the same amount of work, except for now, I have a lot of people's opinions, right? This direct attribute mapping is a smell. The other one is attribute bloat. Anybody know how many attributes a VPC has in AWS? 27. How many attributes does the AWS Terraform module have for VPCs? 220. I can't think of 220 animals, let alone like 220 attributes of a VPC, right? And when you look at it, it has 113 contributors. That's pretty wild. 113 contributors on a single module. This isn't literally Kubernetes, right? This isn't Vault or Terraform itself. It's 113 people's opinions on how you should configure your VPC. What in the hell are we doing? Like the Terraform registry seems like such a waste of time. Like knowing how you want to run this and encapsulating your team's expertise in here is what matters. I should be able to say, we're always using IPv6 inside of my internal networks. You don't have the ability to turn it off. We want to do that, right? And what I tend to do is absolutely abuse the shit out of locals. So there's this concept of variables, which is what you take in. Locals are effectively private variables, but you can use them to kind of collect logic and build up a lot of expertise in your modules. I actually start every single Terraform module I make with a block of locals, no variables. And you'll even see this in some of my code. You'll see there's literally locals that are hard-coded to true. And it's like, I might expose that eventually, but like I don't need to now. And so when we kind of lean into this, our product Master, we have a bunch of Terraform modules that we open source. We don't put them in the registry because we don't want 1,000 people's opinions, but this is our AWS VPC module. It has 5 fields. There's over 200 networks around the globe that are using this module that are running through our platform. And 5 fields. Will this work for everybody on the planet? No. Does it work really well for our customer base? Yes. And like that's all that matters is, do my developers get what they need out of it? Not do I have everybody's opinion in the world? And what we're able to do is we're able to pack a ton of logic into this. You see this last field, network automatic. If you turn this on, it will ignore the CIDR address that you put in, and it will actually scan your entire AWS VPC. It will pick a subnet that makes sense that you'll be able to peer with in the future, and it does all the CIDR math for you. That looks a lot more valuable to me. That looks like somebody has encoded some expertise into something instead of just saying, hey, you tell me what the name is, and I'll pass it to the name field. Oh, and also let me know what that replica name is. I'll pass that one to the other name field. And so this is what I think is important about Terraform. Is like you want to encode expertise in these things so your team can get value out of them, right? You want to create standards across your organization, and you can't really do that with the way that we use the Terraform registry modules today. So if you take anything away from this, it's if you're not familiar with a service, look at a Terraform registry model and see what resources they use, and then go write your own. Like, just go write your own. This is another one that we have for, I think this is Aurora Postgres. Yeah. And so we do things like we handle the naming conventions. In case there's ever a failover and one of our replicas get promoted to primary, this takes care of the naming convention of those replicas to make sure we never end up with something silly like a primary named replica. Right? And so like this is the kind of stuff that we try to build into what we do. We also have this concept of like, we never want to see a database sitting on a public subnet. Who wants to see a database sitting on a public subnet? We got any Heroku users in here? Sorry. I love taking shots at things. They'll get one at me too. They'll be like, they went out of business. But so one of the things that we have is we have this concept of internal and private. Like all of our modules expose, do you want this thing to run internally or private? Can it essentially communicate internally or is it fully isolated? It is impossible to make one of our databases run on a public subnet because we don't even expose like the subnets to you. We say, how do you want to run it? Internal or private? That's it. We don't say what subnet do you want to put it on, what IP address do you want. We take care of all that placement inside our mask behind the scenes. That's also stuff that people aren't like super excited to do. But it's not just about maintaining the code, it's about the infrastructure environment too. And so this is kind of something I see a lot. It's legacy from a time when Terraform didn't have the concept of workspaces. And so to get parity, you had to copy directories. It's so stupid. But it's still today, especially in huge Terraform code bases, you'll still see this. If I want to have production, I make a production folder and I copy all the modules into it. That makes parity really hard, right? Like if I want to add something to my database, I want to start maybe using IAM roles for authentication, right? I add an IAM role resource in there. I have to remember to do that to staging, right? We'll get to that in a bit. So what's really interesting here is there's a lot of stuff to sync. You can't guarantee that parity, but what's really interesting is it's actually not declarative anymore. You have actually one massive switch statement in your head of like, where is this? Is this production code or is this staging code or is this a preview environment code? Does preview environment code use the staging environment Terraform code? Like what uses what, right? And if all this stuff is different and somebody says, you know what, we need database replicas in prod, and they add a database replica directory under here with some database replica code in there, you've actually completely lost parity. You don't have database replicas in staging anymore, right? Somebody says, well, we need parity in staging. What if they didn't realize that there's a separate directory in prod and they just add a replica to that database folder? Like now you don't even have parity in the code, let alone in your environments or in the way that you provision these environments. And there's two types of parity. There's architectural parity. Crap, I left a slide in here that I meant to delete. I'll skip over it. There's architectural parity and then there's scale parity. And so this is one I'm going to skip. I'm just going to go right to the next one. That's actually a picture of our platform from like a year ago that I don't know why I put this screenshot in there because then I went and did this really, really fancy looking one too. So these arrows might look backwards to you. What I'm trying to show here is the flow of configuration information. If you think about Terraform and you think about all of your modules, whether they're together or across a couple different life cycles, you're really looking at a DAG, right? I need to make a network before I can make a Kubernetes cluster, and I need to push some subnet information forward. I need to make a network before I make a database, and I need to propagate some sort of network information forward. Same thing, Kubernetes has to exist before the applications that are running on it. The database has to exist before my backend will ever be able to boot up and connect to it. So architecture parity is about having the same resources in any environment despite their scale, right? If you are using Postgres and you try to save money, you're like, let's not put a replica in staging, we're gonna save some cache there. Well, you actually don't really have parity in that environment. Like you don't know that your reader configuration code works until you go to merge to production and it doesn't. You're like, damn, I wish we would have spent an extra 30 bucks having a replica in staging. That 30 bucks is cheaper than your morale at 2 a.m. And then there's scale parity. CPUs, memory, disk. Instance types are kinda allow you to like have flexibility on parity there. It gets weird now when some of these instance types have dedicated types of RAM and GPUs and whatnot, and then replicas. And I think this is the really important one, is focusing on replicas as a part of parity. I always have a replica, and I might scale that number of them. That's fine, but at least I have the concept of a replica so that I can test for my code that I'm able to communicate with a replica and to a primary database. And so kind of going back to this example here, like you can't enforce staging replicas in this scenario. So if we're kind of in this old model where we're saying, okay, we're gonna add a directory of Terraform for every single set of resources, and somebody says we're adding replicas here, there's no way that you can ever guarantee parity in staging until you copy that. And now when somebody makes a change to a module in the database replica, you have to make a change again, right? And there's still so many code bases, so many customers that we see that are still doing this because they're in like the Terraform like 0.7 days still, right? It's a difficult programming language to kind of migrate and move forward and change from some of these old patterns that it had. So lifecycles are another thing that's very interesting. And I'm gonna show you guys a code sample here in a minute. I'm really curious what your thoughts are. Lifecycles are when the resources are created, or in a declarative world when they're applied. You don't create and update them, you're just always applying the configuration to the cloud. And most importantly, when the resource is deleted. And this one's super important. We should kind of consider the dependencies of our resources and like the relationships between them. And so what I'm gonna do is tell you a story about a guy. But we're in a blameless world, right? We don't blame people. So I'm not gonna mention his name. But this guy deleted prod twice in one day, like back to back. Deleted it before lunch, we fixed it during lunch, he nuked it again after lunch. And no, it was not Rails migrate. It was he made a mistake in a configuration in Terraform, and he missed the fact that it was going to recreate the database. Oh shit, ran it. Oh, and the funny thing is Terraform will exit 0 and say everything's applied. It won't tell you that it took down your site or destroyed your data in the process. It applied the thing that you wanted to do. Did we panic? Goodness, no. I don't know if anybody gets that. If you have kids, maybe you do. Pete the Cat reference. We had backups. And this is interesting. Where do backups fit in the picture in infrastructure as code? Where do they fit in the modules? So breaking up these modules by life cycles and thinking about the life cycles, not just the use case, but the life cycle of these resources, it gives you smaller modules, faster deploys. This is all good for CI. Lowers that cognitive load, smaller commits, this is all great shit. But safety is the important one. And so if we look at this module here, I've seen plenty of times where people are like, this is great. I got a KMS key, we're gonna encrypt the thing. That's good, we encrypt it at rest and in flight, right? We actually turn that encryption field on, which is off by default in the cloud. Why is it still even an option? It's got a backup vault. I've got a backup plan. It's taking daily backups at whoever can do the math on that cron. I certainly can't anymore. And then it's gonna make maybe my database instance. This is a great module. It's got encryption, it's got backups. I destroy the database, accidentally run a down on this. Guess what? My backups are gone. My encryption keys are gone. We're out of business, right? But it's very easy to think like, oh, I've got all the stuff that I need here until somebody accidentally runs a destroy, right? And so when you think about the life cycles of our resources, you kind of think in this DAG again. I need keys to be able to encrypt my database. That's a separate module. And I might put them together in maybe a workflow or a pipeline, but I keep it as a separate life cycle, separate module, separate state. And I can propagate those keys using whether it's Terraform state or something else. I can push that data into my database, and now I have the ability to encrypt it. But if somebody nukes that database, I still have my keys. That's important because these backups are also encrypted with that same key, right? And so I've seen this before where somebody nuked a key and all the backups were encrypted, and it's just like, well, whoops, what do you do? So thinking about these life cycles of like how the resources need to live together and outlive each other, I think is very important. And so when I'm building Terraform modules, I tend to ask myself a couple of questions. What goes in this life cycle? I look at the main resource, and I'll actually put all these resources. I'll actually make that code right there. I'll put all the resources in there in my first draft, and then I kind of look at everything that is adjacent to my use case. I'm making a database, keys. Okay, well, if they're side by side, and I'm looking at them both, if I stop using my database, do I still need the keys, right? If I stop using Kubernetes, do I still need my network? You would not believe how many Kubernetes modules I've seen that also make the VPC. It's maddening. It's got its own network inside of the thing. It doesn't need one underneath it that's in the same life cycle. If I stop using Kubernetes, do I still need my VPC? Probably. Maybe I move to Nomad. Maybe I decide to go back to EC2 instances. If I stop using Postgres, do I need my replicas? Probably not. If I'm decided to migrate off Postgres, I probably don't need my Postgres replicas. VPCs and Kubernetes, separate modules. Postgres primaries and replicas, same modules. Second question I ask is, sorry, not as far ahead here as on here. What happens if disaster strikes both of these things at the same time? If my primary database is destroyed, do I want to destroy the backups? Right? And so I'm literally looking at every single one of these resources in my Terraform, like if this thing gets destroyed accidentally, do I want to destroy this thing accidentally too? And if the answer is, oh God, no, then that's a separate module. So, quick pop quiz. Should I be able to apply the exact same Terraform configuration twice? Once in prod and once in staging and have it work. The exact same parameters. Exact same name, exact same everything. Yeah, I think when you make a really good Terraform module, I could take the same thing and I could apply even in the same AWS account with uniqueness constraints on names like buckets and stuff like that. I should be able to apply the exact same configuration twice. My inputs are parity. My dependencies are inputs, they're parity. I've codified my naming conventions. I'm not gonna have a conflict. I've got a 1 in 10,000 chance of two S3 buckets having the same name because I put a random prefix on the end of them. Being able to have this ability to take a configuration that you have that you're trying to debug at the infrastructure level and say, you know what, I'm just gonna put this in a separate AWS account and clone the entire thing. That's a lot of power. That gives you a lot of power as an operator to be able to debug something without hopping in and potentially taking down a production system. Getting that fresh workspace that you can just bring up that's identical, or a regional migration. I want all this exact same stuff, but in US East, or not US East. You're migrating out of US East for real. Like you're going to US West, right? Or if I'm trying to have regional parity, we're starting to boot up in the EU, and I want 100% isolated exact same infrastructure there. I want to be able to deploy that exact same module twice. So, you're welcome. So, kind of summary, create use case specific modules, come up with naming and tagging conventions and build that in your module. What I'd actually suggest here is make a naming module and use it everywhere. So your conventions are just applied across the board. Avoid the huge registry modules. You're not getting anything out of them. Go and look. Go grab one of the big ones and grep for the word local and see like how much actual logic they're putting in there versus just direct mapping. Design for parity and break modules down into dependency lifecycles. And this is the part where I'm about to get nervous. So, at the beginning, I said I was going to show something we're about to open source. This is raw, and this is a good chance of just imploding in my face. So if you don't care, feel free to go grab a coffee. I will not be offended. But if you're interested, what I'd love to know afterwards, so we're going to aim for like probably late April to open source this. If this is something that you think would be useful to your team, we're looking for probably about 40 companies to start playing with it until we get to the point that we're ready to open source it. A lot of our IP is just still embedded in the middle of this thing. So let's go ahead and give it a go. So let me escape out of this doodad real quick. And we're gonna go, there we go. Well, okay, dokie, let's do this. Clear, bonk, clear. Okie doke, so I have an ops side and a dev side here. And a lot of times I'm working with Terraform, you know, and a lot of companies still, our definition of DevOps is very varied from company to company. People have DevOps teams, people do full DevOps where the developer does the operations, and then people still have this old world where you have an ops person that does all the infrastructure stuff and devs do some. And in any of those worlds, managing IAC is extremely difficult, right? So where does the Terraform go for our networks? Now, maybe in the ops team's repo. What about or maybe the network team's repo? What about a Kubernetes cluster? Maybe it's in the ops team's repo, or maybe each team's running their own Kubernetes cluster. Okay, we got some Terraform here. I got some Terraform here. Now we start getting closer to our app, right? A lot of cloud resources are very app specific. Queues, buckets, databases, et cetera. Who owns that? Where does that go? Do we have a central repository? Does the ops team have a repository? Or does each one of my services have a Terraform directory? Okay, well, so now I got a repo with some networking Terraform code. I got a repo with some Kubernetes Terraform code, and then I've got 15, 20, 30, 40 apps that have a directory of Terraform code. As an operator, how do I guarantee compliance is running across all this stuff? I just hope and pray that you copied the CI pipelines that run checkoff and sneak and all the other stuff, right? And when we want to change the checkoff policies or the OPA policies, I just have to hop into a Slack and say, hey, everybody, make sure you go grab all the new policies for Postgres, copy them to any of your Postgres directories, and please don't make me go and look around all the repos to see if you did that. And so like the way that we package IAC and distribute it today is very much go copy and paste it or reference it, right? And then also make sure you copy the appropriate CI pipelines. Then I, as an operator, we decide to move to a new version of Terraform. What do? I got to go update every single one of those CI pipelines to say, okay, let's bump it to Terraform 1.7. And so we're going to do a demo here today is a tool that we're working on that allows you to package your IAC, all your policies, compliance, naming conventions into a single deliverable, very much like a Docker container, and then ship that to your developers. And so if let's go here. I do md push t acme billing database. So this is just a Terraform directory with some policies and whatnot in it. And I go ahead and push this. It will bundle it up, ship it off. Then if I switch over to my developer pane here, I can do md list. And this will show me all the Terraform modules that my company has published and is sharing. I don't have to go hunt and peck around a bunch of different GitHub repos. We don't have to run our own Terraform registry. And I can see there's a couple of them in here that are built by us, these private ones for Acme Corp. And I can see that somebody's pushed some bastards pushed the Terraform AWS Aurora Postgres module in here. And so I go, oh, you know what? Like I need to update the billing database. What exactly does that do? Okay. This is it's in our repo Acme, it's billing database. I can see the description. It's actually an EC2-based Postgres with PG crypto and timescale DB extensions in it. It's going to run Terraform, checkoff, infracost, and it actually ships with 2 presets. So if I'm a developer and I want Postgres, but I've actually never done all the configuration, I don't know how to do high availability, there's actually a preset there that'll do high availability as a baseline, and then I can do some customization on top of it. It's my preview environment or my staging environment, and I just want some burstable class instances. There's another preset there I can just grab. And now my CI pipeline as a developer is a single line of code. It's apply, the module I want to apply, my naming convention, a preset, and then the configuration that I want to apply. And what you'll see is it's able to grab all of our tooling. It's going to run a Terraform plan. That's OK. It's running checkoff. That's OK. It's calculated infra cost. That's OK. Starting to apply the Terraform. Thank you. Generates an artifact. This is the actual credentials for this Postgres database, stores it in an artifact store behind the scene. So now I'm ready to be able to grab this credential and I want to connect it to an application. And now as an operator, I can come over here and say, you know what? We've been distributing these Terraform modules. Who's using this Acme billing database? Oh, we got 4 instances of it running. I can see there's a billing one that was just deployed. There's a staging one. There's a couple of PRs that are open. And as an operator, nothing's changed about my life. Like I use Terraform, I use OPA, I use Sneak, whatever I am. And I just ran that one bundle and publish tool and it packaged everything together. And as a developer, my life is actually better. I didn't have to copy Terraform. I didn't have to copy CI. I didn't have to learn Terraform. When you look at this JSON file, it's literally just some parameters that I'm going to push in as TF vars or Helm values YAMLs. It actually works with all IAC. And then the really cool thing as an operator is I can say, okay, well, give me the inventory of this thing. And there are my instances. I can see my security groups. I can see the secret where this credential is being stored. And so the goal of this is to make it very easy for operators to start to truly encapsulate this stuff and make sure there's no way that you can come out of compliance by a developer forgetting or not knowing that there's just a copy of a specific CI pipeline, or you're running extremely old policies because you haven't updated some repo somebody forgot about. So our goal is we're going to get this into people's hands, I think, by KubeCon in Paris in like 2 weeks. 11 days, that one's in my mind. And then the goal is to get it out into the public probably towards the end of April. But if anybody is interested in getting access to this early, we have a private repo that we'll be able to add people to. We're trying to get people to use it. Definitely not on production yet. I would not put it on production yet. But we're looking for people to kind of start using it, give us feedback. What's it missing? What sucks about it? What's great about it? Because we want to make sure that when we get it out there, it's a really great open source tool. Because unlike what some companies say about people in the IAC space, we're not all scumbags that just want to steal other people's open source code and make money off of it. Thank you.
Thought the secret to not destroying yourself on the journey is to imagine if your stuff gets deleted. Any questions? You out them. They are stunned, and you did a great job.
Thank you.
Yeah.
I am so excited that that did not explode because this morning I was just getting stack traces, so I'm walking on sunshine right now. Cool. Thanks so much, everybody.